For nearly 3 decades, commercial aviation has flown at the same speed. Not because we couldn't go faster, but because we chose not to. In 2003, the Concorde made its final flight. The world watched as the only supersonic passenger aircraft ever to operate commercially disappeared from the skies. It was the end of an era, and for many, it felt like the future had slowed down. Since then, every commercial jetliner, no matter how modern, how efficient, how advanced, has cruised at roughly Mach 0.85, about 85% of the speed of sound. New engines became quieter. Aircraft became lighter. Cockpits became digital, but speed stood still. Until now. Because aviation is preparing to break the sound barrier again, and this time, the mission is different. The Concorde was a technological marvel. It crossed the Atlantic in under 3.5 hours. It flew higher than conventional jets. It symbolized ambition, but it was expensive, fuel-hungry, restricted by noise regulations, and economically fragile. When it retired, the industry shifted its focus. Efficiency over speed, range over velocity, sustainability over spectacle. For years, supersonic flight became a relic of the past, a chapter in aviation history. But history in aviation has a pattern. What seems impossible rarely stays that way. Today, a new generation of aerospace engineers, designers, and entrepreneurs are attempting what many thought was commercially unrealistic: to bring supersonic travel back sustainably. This time, the question is not just, can we fly faster than sound? It's, can we do it responsibly? Modern supersonic development is not about luxury alone. It's about efficiency through innovation. New composite materials, advanced aerodynamics, digitally optimized engine design, noise mitigation technology. The sonic boom, once a regulatory barrier, is now a research priority. NASA and private aerospace firms are testing low boom configurations designed to reduce ground disturbance. The goal is not simply speed, it's acceptable speed. The difference matters. In the 1960s, supersonic travel was a symbol of national prestige. In the 2020s, it must be economically viable and environmentally aligned, and that shift represents something bigger than technology. It represents aviation has always advanced in cycles. Risk, innovation, correction, refinement. The first jetliners were loud and fuel-intensive. Now they are optimized marvels of efficiency. Early autopilot systems were basic. Now aircraft manage complex flight envelopes. Supersonic travel is entering its refinement phase. But this time, lessons from the past guide the design. Fuel efficiency is central. Sustainable aviation fuel compatibility is prioritized. Noise footprints are studied in simulation before prototypes fly. Certification pathways are being developed in collaboration with regulators from the beginning, not retroactively. That is a major change from past eras. Modern aerospace companies understand something critical. Innovation without certification alignment is delay. Innovation without sustainability is resistance. Innovation without economic viability is short. So what makes this moment different? 2 things: technology and demand. The world has never been more connected. Business is global. Time is currency. Transoceanic travel remains essential for executives, diplomats, and global industries. Hours matter. Reducing a 7-hour flight to 3.5 hours changes productivity. It changes logistics. It changes opportunity. But the modern passenger is different too. Speed alone is not enough. Passengers demand sustainability, transparency, reduced carbon impact. That means next-generation supersonic aircraft must meet standards that Concorde never faced. And that is the real challenge. Breaking the sound barrier is not the hard part. Breaking it efficiently, quietly, and responsibly. That is the challenge. Prototype testing is already underway. Advanced wind tunnel validation, digital flight modeling, engine optimization for lower emissions. Regulators are studying new frameworks for overland supersonic travel. For decades, overland supersonic flight has been restricted due to sonic boom impact. But if low boom technology proves viable, those restrictions may evolve. If that happens, the implications are significant. Imagine New York to Los Angeles in under 3 hours. Imagine transatlantic travel that feels regional. Imagine global commerce operating on compressed time. But here's the deeper story. Supersonic flight represents something psychological. Aviation has often been about progress. From propellers to jets, from analog to fly-by-wire, from manual navigation to satellite precision. When Concorde retired, many believed aviation had entered a plateau phase. Incremental improvements, fuel burn optimization, cabin upgrades. Important, but not revolutionary. The return of supersonic travel signals ambition again. It tells the world that aerospace engineering is not finished pushing boundaries. That innovation is not linear, that bold ideas can re-emerge stronger. Of course, challenges remain. Economic modeling must support operational costs. Infrastructure must adapt. Maintenance, complexity must remain manageable. Air traffic integration must be seamless, and public acceptance must be earned. But aviation has overcome complex transitions before. The introduction of ETOPS changed long-haul twin-engine operations. Fly-by-wire transformed cockpit philosophy. Composite airframes redefined structural design. Each innovation faced skepticism. Each required proof. Each eventually became standard. Supersonic aviation now stands at that same threshold. Not guaranteed, not certain, but possible. And possibility is where aviation thrives, because aviation has always balanced the forces. Safety and aspiration. Speed must never compromise safety. Ambition must never outpace certification. That is why modern supersonic programs emphasize collaboration with regulators early in development. Transparency is strategy. Data is credibility. The skies are not conquered through speed alone. They are earned through trust. And that may be the greatest lesson from Concorde's retirement. Technology must align with its era. Today's era demands sustainability, data-driven validation, environmental accountability. Supersonic aviation's return is not about nostalgia. It is about reinvention. It is about taking a once iconic concept and rebuilding it with 21st century priorities. And that's what makes this moment inspiring. Because aviation does not move backward. It reimagines. The sound barrier is not just a physical threshold, it is symbolic. It represents limitation, constraint, resistance. And every time aviation breaks a barrier, it redefines what distance means. The Wright brothers broke gravity's grip. Jet engines broke speed limits. Digital avionics broke analog boundaries. Supersonic travel may soon break time perception. The future of flight is not only electric, not only autonomous, it is also faster, smarter, more deliberate. The return of supersonic travel reminds us that progress is cyclical. That ambition returns when technology catches up with vision. That what once seemed impractical can become refined. And perhaps most importantly, that aviation never stops evolving. Because in this industry, the question is never simply, how fast can we go? It is, how responsibly can we advance? The next decade will determine whether supersonic commercial travel reclaims its place in the skies. But one thing is certain, aviation is once again preparing to challenge its own limits. And when it does, world will feel smaller, opportunity will feel closer, and the horizon will move forward. Aviation has always belonged to those willing to push boundaries, and the sound barrier may soon echo again. If you believe aviation's future is still being written, subscribe to Flight Deck Stories, and join us for the next chapter in the evolution of flight.